Okay, today is December 17th. Today we will be doing a presentation about how would be the operation of a main station on Mars. I'm Professor Julio Rezende. I'm based in Brazil. And this is one of the most important infrastructures for a station on Mars. Okay, in this case, it's possible to see in this slide how would be the characteristics of a station on Mars with main 7 facilities: the power station, engineering center, sanitation center, a greenhouse, health facility, launch center, and main station. In this case, we'll be doing a presentation about main station. Main station is supposed to be the first infrastructure on Mars. Okay. Also, the main station would present the support to other infrastructures to be operating in the master phase. This presentation will be about main 5 topics. Will be internal design and also the support technologies, management protocols, and also the spin-offs. Okay. Initially, I'll be talking about the internal design. In this case, we had a discussion, a contribution from a Brazilian student, a girl called Mariana Guerra, and she's an architecture student in Brazil. And she proposed not only one infrastructure, but 3 infrastructures working together. In this case, also proposing not a circular shape, but a hexagonal shape, because would be possible to combine these infrastructures like a CAM, okay, integrating the facilities. And these facilities were announced with 3 Greek names, also 3 letters, called Alpha, Beta, and Gamma, okay? This first building is the Alpha, is for prolonged use. It's a silent sector, is for resting. The second building, the Beta, is for entertainment. And the third building, Gamma, is for working, okay? In this case, in the Alpha model, we have the bedrooms, the study room, and restrooms, a place where all astronauts in the station sleeps here, okay? Also in the second facility, the Beta model, we have the kitchen, the dining room, the living room. In the third model, we have the mission control and training and research room, okay? In this case, these facilities is supposed to be working together. In Alpha model, we have some characteristics like 14 bunks. In this case, 5 bunks and 5 bunks in the second and third floor, and also 4 bunks in the first floor, the ground floor. Okay, also areas to luggage, also 2 bathrooms and a study area. Okay, for the resting of astronauts. Also presented some greens inside the station, because some reasons for the plants aboard is to evaluate the air quality, brings nature to space habitats. This is also important to psychological well-being and less stress and more healthy and well-being. Also, other reason is the possibility of vegetables production bring practicity and easiness to prepare a fresh meal, according to the concept of pick and eat, and also would be helpful for meditation. Also in the Alpha model, we have the dormitory with some bunks. Also combining content for like in this case we have two examples of written content. It's in the first photo, astronaut reading a book, and the second photo, the astronaut reading a PDF, okay, in the computer. In this case, would be important we have maybe both, or maybe digital content for astronauts. In the second model, the Beta model, we have a kitchen, dining room, and also a living room and a gym. This is a photo from a platform in Kitely. Okay, it's proposed by Michael Lowry. Uh, in this photo, it's possible to see like a swimming pool, also some music instruments for the entertainment of astronauts. Also in this facility, we have the kitchen. In this first photo, it's possible to see uh, some food cultivated indoors. In this case, would be very interesting. We have the easiness to collect the food to prepare a meal. If you are preparing a pasta, it's possible to take some basil to put in the sauce of tomato. And the second photo is interesting technology just available is a robot to support the preparation of meals. Okay, it's supposed to be operating using image learning with the capacity to read the labels or to follow the orders presented in a video of YouTube. And this would be an interesting technology, support technology to prepare the meals. Also, a dining room, the gym. Here also some photos from the different workouts developed, and also a concept. Okay, how would be the physical activities on Mars. In the third model is the gamma model. It's for the working activities. In this case, the three floors we have the research room, the training room, and also mission control. In this case, we have here in the right side how the panel of the vehicles, the space vehicles, presented a evolution. Also present some screens, small screens. In the last photo from Dragon capsule from SpaceX, using like a typical computer screens with multitasking resources. Okay, and we imagine that for Mars HABTAT operation, we would using operating systems like this to control many different systems part of station. In this case, in the main station is very important. Is very important control center for management and communication. Some topics, some to be controlled is related to the operation of greenhouse and operation of power station and health and sanitation, also the main station. This case relate to greenhouse for the commander and the crew about the main station is very important. Know about the levels of oxygen and carbon about the greenhouse, also the water demand for and consumption, also the temperature, also demands for energy, also how is the levels of food production. Okay, because we in the aboard of main station we have the kitchen and you need a collaboration from greenhouse in terms we have information about what vegetables had been produced during last day or during last week, because this would guide the chef in the kitchen to prepare the meals. Okay. Also, it's very important to control health data from astronauts, different aspects. Also relate to power station, we need to know about how is operating the energy production from different sources, like kilopower, the nuclear fission plant, also from solar, or also from the biodigester. Also, how is working the consumption of energy and how is the demands. If you will have like a extravehicular activity using rovers and vehicles, how would be our planning in terms of the energy supply to the vehicles? Also, one of more important facilities, in my point of view, is the sanitation center, because sanitation center is the place responsible for the production of oxygen, okay, oxygen and water, water from the like reclaimed water, because all the sanitation, all the sewage need to be treated and transformed and recovered to clean water again to be reconsumed in the station. Okay, in this case, the sanitation center is like the heart and the lung of the station, because if you don't have the clean water and clean air, oxygen for astronauts, all the station would collapse. In this case, it's very important the operation of sanitation center, and also it's necessary to know how is the demands for water and how much water we have storage. All of these aspects are important. Also from main station, we command the extravehicular activities. In this case, it's necessary to know about the conditions in terms of weather, external weather, lightning, also if there is a possibility to happen the wind and dust storm, all and how much energy is necessary to operate the extravehicular activities. In this case, from the main station, we'll be controlling a lot of aspects, contacting also the other facilities of this Mars station. Now we'll be talking about the third dimension, important to the operation of these stations are the applied technologies. In this case, in the kitchens is important technologies just used on Earth, like oven, fridge, also entertainment area. You need to virtual reality headsets, also spa hydro message, also disco lightning. From the control center, you need communication and information technologies and antennas. Some important point is discuss about possible resources to generate in situ or transported from Earth. In this case, almost everything will be transported from Earth to the operation of the main station. Some utensils would 3D printed on main station. Also, part of food would be produced in Mars greenhouse. Now I'll be talking about management. In this case, we are imagining 4 positions: the commander, the executive chief, the chef, and general assistant. In this case of the commander, the profile is someone with a multidisciplinary background, someone from management or industrial engineering, someone with a high capacity of leadership, intercultural competency, high personal resilience, and some duties are the control of extravehicular activities, also integrated with the chief of engineering center. Also propose routines or operational protocols, provide guidance to avoid the risks, also conduct educational activities and train the astronauts, preparation for EVAs, also coordinate daily communication routines with some Earth space agencies like NASA, ESA, and ISRO, and all the space agencies from Earth. Also, he have communication with facilities and crew, and sometimes with specific astronauts. The second position is executive chief, would be an engineer, information technology specialist, or a psychologist. And some duties are monitor operations, keep all facilities running, monitor routine maintenance, organize a specific operation, coordinate training, organize a specific operation, and stimulate self-sustainability when each one is observed self-organization, self-maintenance, self-fixing, in alerting other other participants in some cases of emergencies. The third position, I believe, is one of most interesting positions, is the chef. And the chef, the profile would be a cooker, a cuisine chef, a nutritionist, or a gastronomer. And so duties are define the menu, prepare the meals, food logistics, perform food preparation, also the food waste disposal, cleaning, organization, also assess the team's nutritional requirements, plan the availability of food, define the feeding shifts. Here we have a photo from the Matrix movie. This photo is showing the character Neo, interpreted by Keanu Reeves. He's eating the oat milk. He's in this image. He's complaining because all days aboard of the Buccaneer ship, all the time is the same meal. Okay, and this image also was used by Dr. Sion Proctor in her participation in one of our mission, because she wrote a book about food for Mars, and she was saying that for Mars you need to have a very interesting menu in terms of the different food, or also exciting food to keep the astronauts motivated. Okay, because the meal time is very important, and it's very interesting. We have surprise food or surprise menu in each day. Okay. In this case, now we have more two photos. In a first photo, we have some astronauts meals. In this case, it's a small photo, but it's possible to see like some food inside plastic bags. In this case, in International Space Station, they have something like a straw. When the hot water is infused inside these plastic bags, also the hot water in contacting with freeze-dried food, this freeze-dried food recover the properties. Okay. In this case, we imagine that for Mars exploration, need to transport a lot of food for astronauts with a safe quantity to supply the nutrients for them, to feed them. But also you need to consider the possibility to produce food on Mars aboard of main station, also in the small vertical gardens in the facilities. In this case, is a photo from HABTAT Marte. These are some food produced in HABTAT Marte. In this case, lettuce, also
You're on mute.
okay, I'm sharing the presentation again. We're having some difficulties in the communication from us. Okay, in this case, the last photo is showing some food produced aboard of the greenhouse in HABTAT Marte in Brazil. Okay, in this case, the lettuce, the pepper, and also basil. And the fourth position is the assistant, is someone from engineering. also information technology, psychologists or anesthetists, and some duties are emphasize the team's well-being, the food management, support the chef, coordinate the organization of dormitory, also coordinate the gym, also management of laboratory tools, and also apply psychological service. These are the positions aboard of main station. In the main station, we develop a lot of training skills or some development of new competencies relates to new skills based on situations identified on Mars, also systems operation of training about new technologies and training about specific positions and tasks of each astronaut, and also simulations. Here we have some useful videos from YouTube that can be used to train the astronauts, okay, related to operation of teams, also management of mental health. Also, imagine that aboard of the main station, we have terabytes of information related to music, videos, also books, okay? Also videos related to occupational safety and health, okay? And here are some information about resources necessary for 1 week. In this case, we are the solid food for astronauts is supposed to be 1 kilo. Also water to drink 4 liters by day. Also water to prepare the food, 2.5 liters. And also the water for bath, 2 liters by day to each astronaut, okay? Some guidelines should be provided to other facilities. In this case, main station would be providing guidelines about daily routines, schedule activities, health occupation, health environment, and safety guidelines about how to maintain plants in specific space habitats, guidelines about how to provide harmony and collaboration, also about how to let the astronauts comfortable about to be in space, stimulate self-organization, innovation, creativity, and co-creation, emphasize the team's well-being, also creating interesting content, also stimulate self-sustainability. Okay, now we'll be talking about the protocols. We can imagine some specific protocols to be operating the main station, like protocols for harmony and good relationship and collaboration, also protocols to deal with stress and relationship, protocols to organize the room, protocols for plant maintenance, protocols for food production, and also the infrastructure maintenance. Some protocols of safety and health, we can imagine the hygiene protocol, also the use of wearables to provide some data from Apple Watch, also health data collection from saliva, blood, feces, and urine, also protocols to deal with psychological balance and emergencies, protocols and simulation to deal with accidents. Also for the related to protocol for occupancy and entertainment, we can imagine some parties during some specific days, or maybe one party by week, or sometimes some specific day like the birthdays from astronauts celebrated inside the station. Like we need to look there's some days cultivated on Earth, like Dia de los Muertos from Mexico, also the Carnival from Brazil, also Halloween, United States, Christmas, New Year, and other dates celebrated on Earth that would be celebrated on Mars. Also a spa day or a relaxing day, also board games, also yoga and workouts and mindfulness protocol, also content suggestion based in terabytes of music, movies, and books. A concept of a vertical garden, and also for food microproduction, we need a protocol for cultivation, protocol for maintenance and detection of adjustments, Also protocol for food collection, for rotation and disposal of the plants, best time for irrigation, male and female flower pollination and plant cycle. Okay, some aspects for food microproduction. Also for 3D printing, we are here we have in the first two photos like a, a printer using clay to build some ceramics utensils, okay, like a ball. In this case, it would be very interesting. We see the possibility to about the use of filtered regolith. If you have like a treated regolith and the proceeding the addition of water, trying to create like a clay and using this clay to produce some ceramic utensils. And this would be very interesting for Mars, as one of my dreams. I consider that would be very amazing see this possibility on Mars, the first ceramic gadgets, because our life on Earth, since the mankind had the development, we are surrounded by ceramic utensils in our life, and it would be very interesting for future space exploration when happens these moments in terms of development of the new ceramic utensils like balls and pens and other stuffs like this. Also, other possibilities, the use plastic filaments. In this case, for missions to Mars, we suggest the use of a single plastic. If you look the plastic bags used by to transport the food, the meal for astronauts, all these package is supposed to be grinded and to transform and melted to be transformed in filaments. Here we have some examples of 3D printers, a clay 3D printer, also using metal powder, just available on Earth to be used. Here we have some related to protocols for 3D printing. It's important to have a lot of CAD projects, CAD files to print plates and mugs and other utensils. Also, we are proposing a product degradation and recycling protocol when the discarded items are ground down to particles. Also, ground plastic are further refining into smaller particles in a blender. And in a third moment, small particles are melted and extruded into a plastic filament for 3D printing. And in the last part, it will be happening the additive manufacturing process with recycled filament. Now I will be talking about the last part of this presentation related to spin-offs. In this case, recently, some researchers, they are developing like a gadget to sleep, because for space exploration, one of the challenges is related to blood circulation, because on Earth, all the with the gravity, all the blood's going to our feet, but on space, we have a great quantity of blood in our head, in our brain. In this case, these bring some difficulties, some healthy problems, and the researchers are developing something like a new gadget to help the blood circulation. These are some technologies for sleep, maybe would be applied to Earth. And also some technologies for food production, like this, the VEG equipment aboard the International Space Station. Also, these are also for technologies for learning. Now we are talking about the metaverse, and this is a possible new glass, a headset. It's supposed to be launched in next weeks by by Apple. But it's just available a lot of headsets, VR, virtual reality headsets. We have the experience of metaverse. In this case, the technology of metaverse is supposed to be very operational on Mars, and this would be a very important tool and technology to provide learnings and entertainments for astronauts on Mars. Okay, it's very important to provide to learn. It's also technologies for water saving would be also important to us. In this case, in this first photo, it's from the equipment like a technology related to environmental control life support system. It's a board of International Space Station, and the main this equipment is responsible for the urine recycling, okay, and providing a lot of water to the life of astronauts aboard International Space Station. Also, in technologies for energy savings is a kind of floor when you press the foot here. Is generating energy. Also, technologies for recycling is like this kind of blender to ground down the particles of plastics to produce the ground plastic to be transformed into filament. From the operation of May Station, we can see the guidelines to be applied to our daily lives on Earth. Related to health, environment, and safety guidelines. In this case, the astronauts would be doing lectures about how they are living there and teaching us on Earth how would be our life here. Also, the astronauts would provide mental guidelines for mental well-being and health occupancy. In this case, also during the beginning of pandemics, we saw some lectures from astronauts like Scott Kelly mention how he lived aboard of the International Space Station and how we would learn from this experience to our daily lives on Earth. Also daily routines and guidelines, and also recycling mindset, like the example of 3D printing applications. In this case, the operation of the May Station, we can see applications to many sustainable development goals related to health and training of astronauts, the quality education, women and men balance, water saving, energy efficiency, also waste recycling, management, and partnership. Also, these are my contacts, okay? And thanks so much, and I'm open to questions, okay?